Good morning. Yesterday, we read about mirrors and reflection and refraction and absorption of different light waves on different materials. Today, we're going to talk about color. What is color? By the time we get done with this lesson, you should be able to tell me what color is. We'll identify light as a form of energy that travels in waves. We'll talk about how light waves travel in and through different mediums or different materials. How do light waves travel? We should be able to explain that color is determined by how light is absorbed and reflected off of objects. And what causes a rainbow to occur? Identify spectrum of colors that make up white light. A spectrum of colors that make up white light. So we'll be using vocabulary words like white light, which is light that includes all the colors of the spectrum. Wavelength, the distance between waves of energy. A spectrum, which is a series or a range of objects, things, or ideas arranged in a particular order. Rainbow, a curved band of colors in the sky. I hope you've seen one of those in person. Prism, a transparent rectangular object used to refract and divide white light into its different colors. Optometrist is a doctor who examines people's eyes to check if their vision needs to be corrected in any way by wearing glasses or contact lenses or by medical treatment. So, what have we been learning about? Well, we've been learning about what happens to light when it encounters different kinds of materials and surfaces. We're going to complete a warm-up activity. So raise your hand if. So I'm going to read phrases and you're going to raise your hand if it is a true phrase, okay? And if it is something that's related to light. Okay, light can travel through an opaque object like a book. Did you raise your hand? I hope not. Put it down. Can light travel through an opaque object like a book? No. What about this one? Raise your hand if light bends when it travels through a glass of water. Oh, all your hands should go up. Yes, light does bend when it goes through a glass of water. Raise your hand if eyeglass lenses are transparent. Yes, that's true. Raise your hand if a flat bathroom mirror is called a convex mirror. No, that's a plane mirror. Raise your hand if a convex lens magnifies an object. To magnify it means to make it get bigger. A convex lens magnifies an object. Yes, raise that hand. Good. Raise your hand if light changes direction when it passes through a lens. Yes, that's true. Light does change direction when it passes through a lens. Raise your hand if you can always see a clear image when looking through a translucent object. You have to know what translucent is in order to be able to answer that question. You can always see a clear image when looking through a translucent object. No, you should not raise your hand. Raise your hand if a flat mirror on the wall is a plane mirror. Oh yeah, that hand should go way up. Well, there are many types of light energy that are produced by the sun and make their way through space to Earth. Some of that light energy is visible to us, and some of the light waves are invisible to us. The visible light energy is what allows us to see the world as we do. So you might be familiar with some invisible types of light energy, such as X-rays, microwaves, and radio waves. Listen carefully to our story today to see if you can figure out and predict what causes a rainbow. Here's Samuel. Samuel is at his stove. It was a sunny Saturday afternoon or morning, and Samuel had invited Amy, Ethan, and Jack to breakfast. It had been 3 days since Samuel had seen Jack and his grandchildren because he had traveled to the city to a special hospital to have his eyes checked by an optometrist. Samuel set up 2 extra easels in the garden next to his easel. He was trying to encourage his grandchildren to paint with him. He had long since given up trying to get Jack to take up painting as a hobby. When he was at the hospital, the optometrist had advised Samuel to rest his eyes, but he found it difficult to give up his daily trip to the garden to paint. Amy and Ethan arrived first. They really enjoyed having breakfast with their grandfather. Samuel always served homemade pancakes, eggs, sausage, bacon, and hash browns. The breakfasts were always amazing. "Hey, Granddad," yelled Ethan, "I'm starving. Is breakfast ready?" "I doubt you are actually starving," replied Samuel, "but it is almost ready. Just scrambling the eggs." Moments later, Jack arrived, just in time to help Samuel serve the breakfast feast. Once the food had been served, Alfie arrived in the kitchen in the hope of getting a tasty morsel. Samuel pretended to be strict about feeding Alfie from the table, but in truth, he liked to spoil him. "You've outdone yourself, said Jack appreciatively. He too enjoyed Samuel's famous breakfasts. "What's the plan for today?" asked Jack, hoping that there wouldn't actually be one. "Well, I'm going to make these 2 monkeys work a little," said Samuel, grinning. "They are going to have a painting lesson, and all 3 of you are going to have a lesson in the science of color." "That just means he's going to talk a lot," announced Jack, and the children laughed. Samuel, Jack, and the children spent the next hour eating, talking, and enjoying each other's company. Ethan secretly reached down under the table and fed Alfie small pieces of sausage, though Samuel was perfectly aware of what he was doing. And then, after loading the dishwasher and tidying up the kitchen, they made their way out into the garden. Samuel had set up the easels under the shade of a large apple tree. Once everyone was settled, including Alfie, he advised the children to pick a subject to paint, something they could clearly see and would enjoy painting. "I'd like to paint the bird feeder," pronounced Ethan. "I think I'll paint that potted geranium," said Amy, pointing to a plant with vivid red petals sitting snugly in a terracotta pot. "I've chosen to sit here and close my eyes," said Jack, and then promptly did just that. The first thing I want you to understand, and I've already explained this to Jack, is that waves of light energy race through space from the sun to Earth, Samuel began. Each type of light energy has its own unique wavelength. So these are wavelengths. A wavelength is the distance between the crests or the tops of each wave. So this is the top of a wave, and look how they're getting closer and closer together. Some waves are longer than others. These are microwaves. These are X-rays. I can't see a microwave, and you can't see one either. We know it's useful. We can't see a radio wave, but we can hear it eventually if we capture it. This is infrared. Visible light is right here. That's all we really get to see is right in this area. Ultraviolet, X-ray, and gamma rays. These are shorter wavelengths because the crests come closer together. These are longer wavelengths because the crests are spread out. We cannot see all of the sun's light energy, but the energy we can see is called visible light. White light is made up of a spectrum of all the colors we see in visible light. So here's visible light. This is a spectrum of light. We can't see this, that's why it's black. We can't see this, that's why this is black. But these are colors, and it's the spectrum or the wavelength that we can actually perceive with our eyes. And do these colors remind you of anything? Yep. This part, this little bar right here represents this visible part of light. And look, you can see a spectrum of light. What does that remind you of? Yes, it definitely is a rainbow. Some light is invisible, such as X-rays, continued Samuel. That's complicated, chimed in Ethan. Not really, said Samuel. I agree with him, said Jack, opening one eye and pointing at Ethan. Well, let me finish explaining, and it might make more sense, continued Samuel. We need light to be able to see. Light from the sun travels to Earth. Most of it is invisible to us unless we have equipment like X-ray machines. The visible light shines on objects in the world around us. Some of the light reflects off objects and into our eyes. Then, parts of our eyes receive that information and communicate with our, where does it go? To your brain, that's right. The brain figures out what colors we are seeing. However, and this is what's really interesting, said Samuel eagerly, the color of an object is determined by whether that object transmits, reflects, or absorbs light. And sometimes it's a combination. Oh, it's so much easier to understand now, joked Jack. Think of it this way, continued Samuel. Look at the grass. It looks green because it reflects green light waves, but it absorbs the other wavelengths of visible light, meaning it absorbs all the other colors. What does absorb mean? Asked Ethan with a puzzled look on his face. He had by now finished sketching the bird feeder and was dipping his paintbrush into some carefully mixed brown paint. Absorbed light is the light that is soaked up by an object and is therefore no longer visible. The color you see when you look at an object is actually the reflected light. An object has no color if there is no reflected light, explained Samuel. So, Ethan has a red shirt on. What wavelength of light is reflected from the shirt? Reflected means it comes in and bounces off. It is not absorbed. The red wavelength is not reflected. Everything else is reflected or absorbed by this. This is reflected. Red is reflected. Everything else is absorbed by that shirt. So the only thing that bounces back to your eye are the red wavelengths. Therefore, you see red. What happens if you wear black and we see something as black? If you see something as black, it means all the wavelength colors got absorbed into that shirt. Very interesting. I get it, said Amy, who by now was painting the terracotta pot. That's why my art teacher said that black materials absorb all colors of light and do not reflect any. So in a way, black is not a true color. It is more a lack of light. That's exactly right, Amy, said Samuel. White is the opposite of that. An object that appears white to our eyes reflects all the colors of the spectrum and absorbs none of them. Is that why people say you should wear white clothes in the summertime? Asked Ethan, who was concentrating hard on painting the roof of the bird feeder. Exactly, exclaimed Samuel. White material reflects most of the light that hits it and absorbs very little. So if you wear white clothing, you tend to stay a little cooler. Who would like some ice cream? Asked Jack loudly. He had grown restless and wanted to do something fun. Yay, ice cream, screeched Ethan. Yes, please, said Amy. Here's an interesting question, said Samuel. Which would melt faster, chocolate or vanilla ice cream? The children frowned thoughtfully. Chocolate, called Ethan. And why is that? Asked Samuel. Because it's a darker color and would absorb more light, said Amy. Very good, said Samuel. Do you have mint chocolate chip? Asked Ethan. That's my favorite, yelled Jack. Mine too, agreed Ethan. Do you have strawberry ice cream? Asked Amy. I sure do, said Samuel. How about we go inside and cool off with some ice cream? Samuel didn't need a reply. Jack and the children were already walking toward the kitchen door. They hadn't realized it, but they had been out in the garden for quite some time, and in that time, rain clouds had gathered in the distance. Moments later, Samuel, Jack, Amy, and Ethan were sitting at the kitchen enjoying double scoops of ice cream. Amy and Ethan had drizzled chocolate sauce on top of theirs. There was even a very small scoop of strawberry ice cream for Alfie, even though Samuel knew he really shouldn't have any. What do you call a ghost's mother and father? Asked Ethan as he licked chocolate sauce from around his mouth. I don't know. What do you call a ghost's mother and father? Replied Jack. Transparents, announced Ethan. Which one runs faster, hot or cold? Ethan continued. Hot. Everyone can catch cold, answered Amy. You've heard it, Ethan said, sounding disappointed. Okay, how about this one, said Amy. Why is it so hot in a stadium after a football game? Samuel, Jack, and Ethan thought for a while, but could not come up with a good enough answer. Okay, Smarty Pants, tell us the answer, said Jack. Because all the fans have left, said Amy, clearly delighted with herself. Look at that, said Samuel, pointing through the kitchen window. It's a rainbow, exclaimed Amy. Oh, no, he's going to tell us how they're formed, said Jack, pointing his spoon at Samuel. Well, as a matter of fact, replied Samuel, a rainbow is a perfect spectrum of colors. We see this spectrum when waves of white light encounter millions of falling raindrops. Just like the glass of water and the straw, Ethan, the light waves slow down and refract when they come into contact with the transparent raindrops. Essentially, beams of white light break apart into the colors of the rainbow. Each transparent raindrop acts as a prism, perfectly splitting white light into all of its colors, exclaimed Samuel. Oh, we used prisms in class, shouted Ethan. It was so cool. It was like making your own rainbow. Lots of people, boys and girls, use an acronym to remember the order of the colors of the rainbow. Roy G. Biv, like it was somebody's name. Roy stands for red, orange, yellow. G. Biv, blue, indigo, violet. Oh, we've got orange, yellow, blue, indigo, violet. A prism is a transparent object such as water glass or plastic that refracts and divides white light into the spectrum of colors. I hope their stuff didn't get all soaky wet. Samuel, Jack, Amy, and Ethan continued to chat and joke and enjoy each other's company. After a while, they returned to the garden, where Samuel continued the painting lesson. He advised the children to pay attention to the angles and qualities of light and shade that hung in the air like soft, clear, transparent wings. He talked to them about texture and tone. All the while, Jack sat in his garden chair and napped. Morning turned to afternoon, and afternoon to early evening, and no one wanted to leave the comfort and shade of the beautiful garden, not even Alfie. So were your predictions about how rainbows are created correct? Well, let's ask some questions to help us solidify the information that we learned. What is visible light? Visible light is light that we can see. You heard that white light is related to visible light. What is white light made of? Remember Roy G. Biv? White light is all the colors that we can see. Red, orange, yellow, green, blue, indigo, violet. Red, orange, yellow, green. So we've got Roy, G for green, Biv, B, blue, indigo, and violet. What is the type of invisible light used to create an image of a body that we learned about? An X-ray. It's invisible, but it is light energy. How does light travel? Light travels in a wave. How are light waves measured? Light waves are measured in wavelengths from the top of one wave to the top of the next wave. Why does a shirt appear red, or any color for that matter, but let's just say red? Well, the red shirt absorbs all of the colors of white light except the red light. The shirt reflects the red light back into our eye, and we see the shirt as red. The colors we see are reflected light waves back to our eye. What causes an object to look black? Black is the absence of reflected light that occurs when all the colors of the spectrum are absorbed. What causes an object to look white? White is what we see when all of the colors in the spectrum are reflected back to our eye. Describe the spectrum of colors and how it is formed. The spectrum is all the colors of the rainbow: red, orange, yellow, green, blue, indigo, and violet. When the waves of white light are refracted in just the right way by a transparent material, such as a prism or raindrops, a band of colors appear. What is an example of a spectrum that you heard about in the read aloud? Well, a rainbow, which is all the light energy from the sun. A rainbow is one type of spectrum, but all the light energy from the sun that includes not only the visible light that we can see, but the invisible light that we cannot see. Those are examples of spectrums. Okay. This is a spectrum of the visible light that we can see. Think of Roy, G, Biv. But this is a spectrum of the light energy from the sun, from radio waves, which are long waves, all the way to gamma rays, which are very short waves. Remember, we measure light waves from the top of a wave to the top of a wave. What does an optometrist do? An optometrist is a doctor, and this doctor examines people's eyes to check if their vision needs to be corrected. Raise your hand if you've been to an optometrist before where your eyes have been checked. It's a good thing to do. You might be surprised at a gradual change in your eyesight and not know that you could use corrective lenses to help you see clearly. In a completely dark room, is it possible to see colors? Why or why not? In a completely dark room, is it possible to see colors? It is not possible to see colors because there can be no color without light. Color is reflected light that enters our eyes. Nice job, boys and girls.